We're given these three matrices, so the I is the 3 by 3 identity matrix, and asked to show there's an integer k for which this is true. Okay, well, I'm just going to create a little bit of space. So the first thing I want to do is work out AB. And let me do it down here. So AB is going to be 4 minus 1, 7, 2, minus 5, 8. This is a 3 by 2 matrix, 3 rows, 2 columns. Then I'm multiplying it by 2, 3, 2, minus 1, 6, 5, 2 by 3 matrix. These two are the same, so we can perform the multiplication. We're going to end up with a 3 by 3. Okay, so first up, I'm going to multiply this row by each of the columns. So 4 times 2 plus 1 starts me off with 9. 12 minus 6, 8 minus 5. Then we go down to the next row. 14 minus 2, 21 plus 12, 14 plus 10. Then the final row, minus 10, minus 8, that's 18, minus 15 plus 48, another 33, and then minus 10 plus 40, 30. So therefore, AB minus 3C, I'll leave the K for the moment. Yeah, I'll leave the K for the moment, is going to be this. Oh, let me just copy it. And I'll be minusing 3 lots of C, so I just times each of the elements by 3. Then this is equal to 24, 0, 0, 0, then 24, 0, 0, 0, 24, which is equal to 24i. And therefore, AB minus 3C minus 24i is going to equal 0. K is equal to minus 24. We're then asked to explain why there's no constant m such that this is true. And the problem is finding BA. So for BA, we've got a 2 by 3 matrix for B, and then A is 3 by 2. So we can actually multiply them together, but BA will then be a 2 by 2 matrix. And we cannot then subtract C, a 3 by 3 matrix. These two matrices are not conformable under addition. That's another way of saying it. Finally, we're asked to show how the matrix C can be used to solve this simultaneous equation. Well, we can rewrite this 3 simultaneous equations in matrix form, because I've got minus 5x plus 2y plus z. That can be written as this row and column. And then that's equal to minus 14, 3, and 7. Well, those are the other ones. But now I can just fill in the rest of them. 4, 3, 8, minus 6, 11, and 2. So C x, y, z is equal to minus 14, 3, 7. And therefore x, y, z is going to be the inverse of C. Because what we were doing is we multiply the left-hand side by the inverse and the left-hand side of this one by the inverse. This becomes the identity. And that's how we end up with the result I've written below. So let's solve it. And for this, we don't need to do the determinant and all that sort of stuff. We can just use our calculator. This is a short question. So matrix mode, I'm actually going to go for number 3, matrix C, because that's just so I know which one's which. 3 by 3. Okay, there's matrix C sorted. Right, I'm going to define then the minus 14, 3, 7. So I'll call that matrix A. So it's going to have 3 rows and 1 column. Okay, and we're ready to do matrix calculations. So I want to find matrix C. And then I want to do the inverse, and that just means putting the minus 1 there. I'm going to multiply by matrix A. And this will give me my x, y, z. So I get 3.5, 3, and minus 2.5. Just realized I've actually done part 2. So all of this together is part 1 and 2. Okay, and we are done. Well done.